Okay, so it's about 7 o'clock, plus minus a bit. So, hopefully, I think I'm sharing the right screen. Yeah, looks like I'm sharing the right screen. So, yeah, it's a Friday, and I hope everybody is doing okay and is doing well. I know it takes some time for people to stream in and to come in. So, I'm going to go through something different first lah. Okay, go through something different first. Okay, so let me play a video. Yeah, mute myself. Yes, I muted myself. Okay. Oh, oops, sorry. Okay.
Star Wars fans would be familiar with the golden light.
Okay, sorry, that was too fast. Okay, so basically, just for the sake of other people that they need to take some time to come in. So, gonna go through a term I don't know if you have heard before, but I don't think we are really talking about it for this module. But the umbrella term for this part of the AI that we are doing in terms of machine learning slash deep learning slash AI is about natural language processing lah. So just for all of you that come early, let's watch this video about what natural language processing is. And if you already know what it is, it's good. If not, it is of course supplementary to what we are doing for this module of generative AI lah. So the fundamentals of generative AI uses the notions of natural language processing, and I find it easier to use the term natural language processing to explain engrams. And today, what we're doing is word embedding stuff. Okay, so this is just additional stuff. Then after that, maybe I will offer what does the skill set of natural language processing, what kind of job scopes or what kind of roles you can actually fit into as you learn this skill set, and does it pay well? Yeah, so let's watch this video first.
Life-sized hospitality robot C3PO. While Star Wars might be set in a galaxy far, far away, the reality of having machines talk and respond to us in a human-like manner is already a reality, which keeps getting more and more realistic with every passing day. The people you ask for queries on websites, your smart assistants, even calls made over the internet, all of them have one thing in common. None of them are actually human. Now, you must be thinking, if they are not human, how do they manage to sound and seem so human-like? How do they respond to me so intelligently? And how are they so articulate? This, my friends, is the magic of natural language processing. What is NLP? Natural language processing, or NLP, refers to the branch of artificial intelligence that gives the machines the ability to read, understand, and derive meaning from human languages. NLP combines the field of linguistics and computer science to decipher language structure and guidelines, and to make models which can comprehend, break down, and separate significant details from text and speech. Every day, humans interact with each other through public social media, transferring vast quantities of freely available data to each other. This data is extremely useful in understanding human behavior and customer habits. Data analysts and machine learning experts utilize this data to give machines the ability to mimic human linguistic behavior. This helps save millions in terms of manpower and time, as you don't need to always have a person present at the other end of a phone. NLP is also a lot more widespread than you may realize. You use it every day in seemingly normal and insignificant situations. Don't know how to correctly spell a word? Autocorrect has you covered. Need to see if your article or thesis will get flagged for copyright violations? That's okay. A plagiarism checker will search through the web and find any cases of published documents which may match your work line by line. While NLP seems really cool, yet a cutting-edge and complicated technology concept, it is actually pretty easy to learn. You start off with a document or an article. To make your algorithm understand what is going on in it, you need to process it into a form which is easily comprehensible by the machine. This is no different than making a child learn to read for the first time. You start off by performing segmentation, which is to break the entire document down into its constituent sentences. You can do this by segmenting the article along its punctuations, like full stops and commas. For the algorithm to understand these sentences, we get the words in a sentence and to explain them individually to our algorithm. So, we break down our sentence into its constituent words and store them. This is called tokenizing. where each word is called a token. We can make the learning process faster by getting rid of non-essential words which do not add much meaning to our statement and are just there to make our statement sound more cohesive. These words, such as are, and, the, are called stop words. Now that we have the basic form of our document, we need to explain it to our machine. We first start off by explaining that some words like skipping, skips, skipped are the same word with added prefixes and suffixes. This is called stemming. We also identify the base words for different word tense, mood, gender, etc. This is called lemmatization, stemming from the base word lemma. Now we explain the concept of nouns, verbs, articles, and other parts of speech to the machine by adding these tags to our words. This is called part of speech tagging. Next, we introduce our machine to pop culture references and everyday names by flagging names of movies, important personalities or locations, etc. that may occur in the document. This is called named entity tagging. Once we have our base words and tags, we use a machine learning algorithm, like naive Bayes, to teach our model humans sentiment and speech. At the end of the day, most of the techniques used in NLP are simple grammar techniques that we have been taught in school. Here is a question for you. Which of these NLP techniques is used to obtain words from sentences? A. Stemming. B. Tokenization. C. Lemmatization. D. Segmentation. Give it a thought and leave your answers in the comments section below. 3 lucky winners will receive Amazon gift vouchers. With the increasing demand for automated language solutions, companies are looking for NLP experts to join them and are prepared to offer highly lucrative salaries as well. If you want to learn more about NLP, you can check out Simply Learn's post.
Okay, so we stop there. That is the concept of NLP. If you have been through that, then it's good. And if you haven't heard of that before, then that is the branch of AI that we are looking at. Generative AI, the fundamental technology is still natural language processing. Okay, so because of that, let's look at the definition of NLP first. The intuition of NLP. So natural language processing is that language is a social habit rather than a math problem. So instead of teaching a computer every grammar rule, we teach it to look for the main role of AI. The things that you do for AI is that you're making patterns, looking for patterns, and as well as today we'll talk about the concept of neighborhoods. So it works because AI treats words like people. You know what a word means by its surrounding. You know what a word means by its surrounding. So this is what we will think about a lot more as well. So similar to its engrams, today's words and embeddings will sort of help you understand what a word means based on the surrounding words or the surrounding context. So today the idea of word embeddings in the form of natural language processing is that it will turn text into a map and they have to relate with each other. So there's a lot of keywords here about proximity. There's a lot of detail about certain words, but we will have this intuition of natural language processing with this aspect for today. Okay, so I know some people are still streaming in, so that's why I think I'm going through peripheral ideas around the idea of word embeddings lah. Okay, so one thing that the video tried to end off is to talk about the idea of natural language processing jobs lah. So you can do your own job research, but just by a simple search of NLP engineers in Singapore, base pay 5K to 9K a month, and then there's another screenshot at the right that says machine learning engineer 6K to 11K. So traditionally, NLP engineers are either called machine learning engineers or data scientists lah. So 6K to 11K a month. And then salaries can be quite high for AI fields lah. But this is data that maybe now and the past few years, but I guess we can't really project or we can't really predict what the salary will be like in a few years' time lah, and how since the AI space and the generative AI space changes very quickly. Okay, so you can sort of do your research and you can sort of look at that lah. But maybe I would just like to highlight one last thing is that some people like the idea of the day in a life of a certain job or certain person. So, so this is a day in the life of may not be the most reliable, but Reddit kind of post lah. So this person says they are considering a career in natural language processing or work with large language models, and they would love to hear what is the day in the life of people and what they do lah. So let's look at two anecdotal answers in Reddit from people that have responded lah. So these are two different screenshots. So one person says spend a huge amount of time building and working with prompts. Reliability, consistency, accuracy are all issues. Can spend a whole day working on prompts to get the right models. So it's a lot of trial and error. Yeah. So NLP engineers, machine learning engineers, usually just work with models a lot. The second line, which under this Dr. Ben Whitman, reliability, consistency, and accuracy, these are the things that you will learn about evaluation and to assess models lah. So how certain AI models, are they reliable? Are they consistent? Are they accurate? All the different terms like this. And if you've already taken machine learning, then you probably know accuracy and then precision and recall. These are the ways to determine if models are good lah. Yeah. So besides that, there's another person that replied at the bottom, tech person 1, 2, 3, and 4. This person says a lot of cleaning of data for RAG systems. So if you're training models or you have not trained AI models before, the thing is that there's a lot of cleaning of data that is being done. So sometimes modeling may be a very small portion, but 80% or more of the time you may be looking at the data on its own. Yeah. So when I used to work with very big data from a semiconductor company, the data was very squarish, meaning that the columns and the rows is quite big. So the columns, thousand over columns of data, because a semiconductor store almost many data points lah. And then it's like millions of rows that's added every day lah. So every few hours, then millions of rows will be added. So data is very huge lah. So because of that, the consensus or the idea was that they wanted to just store data and through the storage of data, and then hope that in the future, this data can be used for something lah. So that includes a lot of capturing data that's not very useful. So just a short understanding is that the day in the life of people doing all this is training models is that you also need to do data cleaning lah. So like you're a data engineer, you must know how the data works, how to clean it, then how you enhance data. In this case, enhance data, I think is more of like scaling data and enhancing features lah. So if you've done machine learning, those are quite common terms that are being used. And then text retrieval methods, how to retrieve data, and a lot lah. So basically just building models lah. Building models lah. And yeah, lah. So those are some of the details for today.
Yes, a bit next. Ui, ui.
Sorry, somebody asking a question. Hello. Okay. If you okay, no worries. It's okay if you accidentally unmute yourself. It's fine. Yeah. So if you have any questions about these, you can we can discuss about it also lah. But that was just to wait. That's just some side peripheral concept of letting you know about NLP lah. Okay. Okay. So okay, wait, sorry. So how come the formatting is spoiled? Give me. Okay, the formatting is a bit odd. Okay, so the formatting sort of was destroyed there, but let me reload it. So today, of course, I'm going to do a refresher on engrams, and then we're going to do word embeddings, and then at the end, if we have time, we will compare between these two tools that are being used to develop AI, generative AI models as of now lah. Okay, so I know it's a Friday. It's a 7 plus p.m. on a Friday. As I said, I'll try to make your time as valuable as possible because it's a Friday night. So I'll try to give you good examples or easier way to learn and to think lah. At the same time, just maybe a bit of me sharing too much is that today I actually was teaching a course from 8:30 a.m. to 6 p.m. already. So I may not be full of energy today because I was teaching a physical course for 8.5 hours or so lah. Okay, so because of that, I may seem a bit tired, but we still follow the model of around 40 minutes of class. Then 5 minutes of questions and 15 minutes break. I know last time I didn't keep to that. But we will see how we can keep to that so you can have a break, can go to the toilet if you need to eat something quickly because it is at night, then I'll try to keep to that lah. Okay. Yeah. So roughly around 7:40, I'll try to give you a break there. Okay. So today we'll talk about it's a refresher about engrams and then the word embeddings. So this topic is a bit more visual. So if you're a visual person, you may like this topic quite a bit lah. So engrams is quite code heavy, but not really mathematically complex. But word embeddings are very mathematically complex, but very visually interesting as well. Okay, so let's go through the intuition of engram. So there's a short refresher. So imagine that you are trying to navigate a dark room by using only a tiny flashlight that illuminates a few steps of you. You don't need to see the front door or the backyard to know that your feet are standing on carpet. So the next step is likely carpet or sidewalk. And this is the core intuition of engrams. It treats language like a trail of breadcrumbs, where the most recent crumbs are the ones that matter for what? The next move? For predicting the next move. Okay, so engrams, you remember the unigram is the single word, the bigram is its word and its adjacent word. Trigram is its the current word, the adjacent word, and the next word as well. Okay, so engrams, you want the context of the words after it lah. Okay, so the context of the word around it lah. So it works for AI. Human speech as speech is repetitive and habitual lah. Okay, so by ignoring the burden of a sentence deep meaning and focusing strictly on the small probability of how words are like, the engram allows a computer to sometimes hallucinate lah. So today I was teaching a generative AI course on not for developing models, but more of like applied generative AI lah. So what kind of generative AI tools are there? So there was this idea about how generative AI some of the things that it's doing is just predicting the next word lah. And then predicting the next word, you just choose the next word that is highest probability, and it may not yield any meaning at all lah. So today we'll discuss this concept of meaning and how engrams it's just predicting the next word, but not necessarily any form of meaning associated with it lah. Yeah. So and that's what some of the generative AI models are also using lah. Okay, so sorry, I digress a bit. So in the last sentence, it essentially cheats at understanding by memorizing the probability, the rhythm, echoes of how we what string sounds together. So how we usually string sounds together. So how we put words together lah. So how we add words together, we're just guessing lah. So inside the lab, you did the engrams of words, but you did also engrams of characters lah. So sometimes it's also quite there's no meaning lah. You're just predicting the next word lah. Okay, so that's why engram may not be the best case, but it can be used very well for feature engineering and feature training of the model lah. Okay. Okay, so for example, there's four sentences over here. I made her duck. Okay, I made her duck. And then this sentence, I cooked a waterfowl for her. Cook a waterfowl belonging to her. I caused her to quickly dodge and magically transform her into a waterfowl. So I made her duck can have the four different meanings, right? So I cooked for her this duck. I cooked a duck that belonged to her. Uh, I made her duck. I cooked her duck. I caused her to quickly dodge. I made her duck, like her head move down, and then I made her duck is I magically changed her into a duck lah. Okay, I magically changed her into a duck. So, do you think Ngram model can actually tell the difference between the meanings of these sentences, or is it just going to predict the next word? Because you see waterfowl, they see for is the next word. Waterfowl, and then the next word is belonging and then waterfall and then full stop. So right now, if you train an engram on this, the probability for for belong and a full stop is about the same lah. Okay, yeah. So it does not. It just does some for probability metrics. Okay, so if you consider this sentence, an object was flying towards her. I made her duck. So she. Now you can sort of what do you call it? Like reduce the definition of I made her duck, right? an object was flying towards her, I made her duck. Could it be I made her cook because the object was flying? Could it be that I cooked her duck because the object was flying? Could it be that she transformed into a duck because the object was flying to her? Maybe if you live in a more magical society, but I think this sort of narrows down to the definition of tree lah. So I caused her to quickly dodge, and that's because when given the context, when given more words that surround, there will be easier way for meaning to occur lah. Okay, and then we will discuss about this meaning and this understanding from a bit of a, I feel more of a philosophical standpoint. Okay. Yeah, so another way to put it is that engrams look at the word and the next word, right? So an engram model may not be able to tell the difference. This is another way to phrase it, lah. Tell the difference between these four meanings because it only looks at a small chunk of words, lah. A small chunk of words, okay? So now we'll word embeddings may be a way to solve that instead. Okay, so let's think about what is happening for the engrams as well as for the in the future word embeddings, but let's think from the standpoint of syntax and meaning now. So syntax is how a sentence is structured. So for example, this first sentence that you're reading, the difference between syntax and meaning is the difference between following a recipe and understanding flavor. So syntax is sort of this idea of how many words are put together to form a sentence that makes sense. That makes sense. So as you can say, I eat food is a sentence that makes sense. Uh, but you can say that I eat the eaten one or something like that. The syntax is correct, but the meaning is not correct lah. Okay, so and another way to put it is that a sentence can be not grammatically correct, but the meaning is understood. So it's a lot of Singlish phrases probably have poor grammar, but the meaning is still there lah. Yeah, so the meaning is still there lah. So meaning like okay, I can't think of an example now lah, but hopefully you understand what I'm trying to say. So the difference between syntax and meaning is the difference between a recipe and understanding a flavor. The engram is a master of Engram is master of predicting the next word and looking at the words in after it, right? So it's a master of syntax. It looks at the words inside the sentence. So this idea is that it treats language like a string of Legos lah. So you're looking at what's the best next Lego piece to put towards it. And then yeah. And then for instance, if a model sees that the storm was, it may suggest loud or coming simply because those words are statistically frequent, statistically common neighbors. So engrams, if the words are more common, then it will just choose the most common words. So, but the idea of semantics, the idea of meaning is that, however, when we understand the intent of weather, it maps the vibe to the entire story, meaning that if the previous structure in the sentence is different, then you have a different definition. So in terms of the idea of meaning, right, the roof began to leak, the storm was destructive. Then you will have more words before it to make a better understanding. So the idea of word embeddings, we will talk about how in the meaning, the semantics, the whole sentence will be used to help understand this, to understand the words that are being predicted. Okay. Okay, so a short question to think about. A, B, C, and D. A, B, C, and D. Which one do you think is accurate answer? So which of these best describe the primary focus of syntax in an n-gram model? Which of these best describe the primary focus of syntax in an n-gram model? So you can type it on the chat or you can keep it to yourself. Either is fine. Yeah, so you can think about them first. Okay, Chikyok says B. Shi Yang says B. Okay, let's let other people think first. Let's let other people think first. Yeah. Okay. I'll leave it as that. Thanks for the responses, Shi Yang and Chico. Thanks so much. So yeah, the generally the answer is B lah. So following the structure, rules, and statistical patterns of words. So mapping words into a neighborhood of similar meanings. So C is plausible. Mapping a word of neighborhood. So I'm trying to think if it is plausible. Mapping a okay. I mean, to a certain extent, okay, because I haven't explained word embeddings, then it is possible. Yeah. So Amanda's question is it plausible? Yeah. I realized that maybe I shouldn't have used this phrasing lah. But you see what word embeddings are, and then you'll know the difference lah. But good try. I didn't think of it that way. But I think engrams, yeah, you can sort of map one word to other words lah. Okay, wait, sorry. Then I realized, but it does not map similar words lah. For engrams, you're just mapping it to the next word, but not words of the similar meanings lah. Okay, not words of similar meanings, which I'll show you that word. That's what word embedding does, and it's quite interesting. It's quite nice to see lah. Okay. So before we do word embeddings, the next thing we want to discuss is how do you define a meaning of a sentence lah. So from now on, the meaning is going to be a bit philosophical per se, because I think it's a bit hard to define what the meaning of sentences are or words are lah. But I'll try my best to explain it if in a more intuitive manner lah. Okay. So sometimes a word that is being used is based on a synonym lah. It's based on a similarity lah. So if somebody asks you how to describe happy, how are you going to describe happy? Let me say, describe the word happy to me. The example of how you will describe the word happy could be use a synonym. You say, I am delighted. Happy means delighted. Happy means a feeling of joy. Happy means joyful. So sometimes words have inherently can be described by a synonym lah. Okay, or in the case here an antonym lah, which is the opposite lah. So happy could be not sad, or the opposite of happy is sad. Okay, so in the case here, this table, I know we may be jumping the gun a bit, but this table, you as you look at this table and you see the similarity, maybe you can make a guess of what does this similarity values mean. Okay, so you see vanish and disappear 9.8, behave and obey 7.3, hold and agreement 0.3. Okay. So if you have done machine learning, this should be quite easy for you. But just by your visual test, you're looking at it and bringing up your intuition, what you will see is that the words vanish and disappear are very similar, right? Are very similar, and therefore it sort of, if I'm not wrong, generally a lot of similarity scores are just greater than zero, and but this table looks like it's capped at 10. So as long as it's on a scale of 0 to 10, the higher the value, the more similar it is lah. So if some algorithms, so I think if you put vanish and vanish, the similarity will be 10. Okay, so hold and agreement, the similarity is very, very low lah. So there's close to no similarity. Yeah, I also don't think when or why would you substitute the word whole with agreement? Okay, probably exists. I just can't think of it as of now. Okay, so similarity is one way for you to describe words lah. Next one is also called association lah. Okay, so something is somewhat similar, somewhat related, and different lah. Okay, so coffee and tea are similar as drinks, maybe. Coffee and tea are similar as beverages. Coffee and tea are similar as uh I don't know, Asian drinks. Okay, I can't think of what coffee and tea can be similar as. But coffee and cup are related because coffee has to be put in a cup. I mean, coffee can be put in a bottle also. But whenever you have coffee, maybe you have cup there. Or maybe when you have cup, you have coffee there also. So it's a form of word association lah. So it's also similar to engrams. The relatedness is similar to engrams. What's the probability of the next word being near to the other word lah? But I don't think people use a score for this now. So similarity, as you saw just now, may have a score, and you'll see the word similarity a lot if you do AI, and that's because you are making a guess on how similar things are, and when things are similar, it's easy to make predictions that way lah. Okay, so relatedness is maybe another way for you to describe similar words together lah. Okay, but another way to put it is how do we define a meaning of a word? Okay, how do we define a meaning of a word? So it's gonna border a bit on linguistics and philosophy lah. But if you think about it, when the headers of this table says without concept and it says without pre-existing concepts, what this means is that how are you going to define it and how are you going to define it without referring to other words lah? Yeah, so generally, how will you define like cat without using any examples? So you can say like without any concept, you see a cat and then a cat can be it has four legs, it has one tail. But when I say four legs and one tail, it still can be a lot of animals, right? It can be like horses, uh, four legs, one long tail. Still sounds like a horse, right? Four leg, one long tail, uh, one head with 2 ears. Still sounds like a lot of animals. Four legs, one long tail. Yeah, cats have long tails, right? Long tail, and then it has whiskers. Okay, then it sounds more like a cat lah. But if you have pre-existing concepts, what you can say is that uh a cat is something that exists on an island that they have very small creatures, and then okay. I find it hard to explain a cat now. Okay, but the cat very hard to explain. Okay, so for what about a bank? Okay, so without any concept, bank could be you can tell people that a bank is like this thing that is beside the river, the dry land beside the river is the bank. Or you can say that a bank is something that you go to deposit your money in the 21st century because this is how we store money. Okay, or pre-existing concepts could be you can say that uh, UOB, OCBC, DBS, these are called banks. Then if people already understand these names, then they will make the association easily lah. Or you can say that when there's water, there is always banks. Okay, there are always banks. So that is like a pre-existing concept lah. So another way to think of it is how do you explain abstract concept like this to a 2-year-old lah, 2-year-old lah. So how you define meaning can be you describe it, what it looks like, or you can use words to explain its function. Without pre-existing concept is that you use associations that already exist with it lah. So when I say computer, the thing in front of the computer, you must know what's a computer first before you know that it's the screen, right? Okay. So that is how you one way to decide how you can define meaning lah. But is it a good way to define meaning? We're not here to evaluate that. Okay. Okay, so first of all, whatever that I just said will be explained in words now. So in case you were lost for that part, let me explain these things in words lah. Let me explain these things in words. Okay, so sometimes we use first of all we explain words with other words lah. So as I said, synonym, antonym, hypernym, functions, relationships. Synonym, I gave you the example already, right? Happy, not sad. Oh, sorry, not sad is more like a antonym lah. Synonym, happy, joyful, delighted. Okay, and other things lah, like functions and relationships lah. So so for example, a relationship is like the word child. If you say a father and mother has a person, then you associate that as a child lah. Okay. So some examples would be cat belongs to a mammal. That would be a relationship. A cat belongs to the family of a mammal. A cat is similar to a dog, even though they are not exactly the same thing, but they have some similarities. They are both pets. They are both animals. A bank is an institution that lends money to clients and borrow money from clients lah. So you're using a verb to define it. And then a cold is opposite of hot. Another way to make a definition. And then running is similar to walking. So the pace is the same, but it is faster. So this is another way to explain it. So there will be examples of word net and word relationships that constitute it lah. Okay, but at the same time, when you want to explain a word or you want to explain pictures, you can also do that lah. So just now the first example I gave was that a cat has two legs, not two legs, cat has four legs, a long tail, a head, 2 ears, and has whiskers, and generally is shorter than 1 meter. Yeah. So you can use pictures or experiences with that. Okay, so if we break this down to a bit more abstract, a bit more academic, a bit university sounding, right? When you want to define a meaning of a word or a sentence, oh sorry, a meaning of a word in this case is that you can look at it as lexical and experimental lah. So lexical is how that word functions when other words are being used. Experimental is how you perceive it to be lah. Okay, so another term for that is lexical semantics and experiential grounding lah. Okay, so so sometimes there will definitely be experiences and ideas for you to take note lah. So so if you can see lexical semantics are the synonyms, antonyms, all these meanings lah. So word relationships. But by your own experience would be another way, which would be the grounding. Let me go back one slide, the experiential and the grounding, because what philosophers also try to argue is that when you are experiencing something, you're also giving a certain definition to it. Lah. How you experience something gives a definition to words as well. Lah. Okay, so yeah. Okay, so let's do a bit of a word exercise. Let's do a bit of a word exercise and a bit of thinking over here. So guess the meaning. We're gonna guess the meaning of certain words, okay? Suppose you see these sentences. Uh, Noyabri is delicious, sauteed with garlic. Noyabri is superb over rice. Noyabri leaves with salty sauces. And you have also seen this. Spinach sauteed with garlic over rice. Chard stems and leaves are delicious. Collard greens and other salty green leaves. So a reasonable conclusion is to say that you have no idea what the word noyabri is, but noyabri could be a leafy green like spinach, like similar to spinach, chard, if not collard greens lah. It could be that lah. So if you read it again, you see these three sentences, noyabri is delicious, noyabri is good with rice, noyabri leaves with salty sauces. Okay, so you can see like you don't know what's noyabri, but then when you're given other context that you know about spinach, chard, and collard greens, then you will have association. So noyabri could possibly be like a vegetable such as spinach, chard, or collard greens. Okay, so noyabri is not a word lah. So noyabri is just a word to demonstrate that even if you don't know any of its meaning, your associations with previous experiences of vegetables may make you feel that noyabri is a leafy green vegetable lah. Okay, so let's look at it in a different way. We can look at Noyabri os diffrius golfet with myth karmic. Noyabri os anbreda oba. Okay, I'll stop reading it. You can look at it first. So take your time to look at it. Take your time to read this. Uh, this is not a language. This is just gibberish per se. So you see Noyabri, you see Noyabri, Noyabri, and then Noyabri is with karmic, and different terms like that lah. Okay, so because you have read the previous sentences, the Noyabri and then the spinach, the chard, and the collard greens, then maybe you would have a different association lah. Maybe you would have associated that Noabri is some form of grimus, like uh Vulgaris grimus and Brassica grimus grants, yeah, like Chenpo, Brassica and Vulgaris lah. So you sort of assume that Noabri is related to these words lah. Okay, but this is gibberish lah. It doesn't really mean anything lah. Okay, yeah. So before we take a break, so what does this mean? What can you take away from this lah? So if you look at these keywords, sorry, should have highlighted these keywords here. So you can see grimace comes out quite a lot. You can see this fatty comes out quite a lot. Then this creasy comes out quite a lot. So you can see the words that repeat itself, then you will form some form of association. I wouldn't actually form this conclusion, but you could have formed this conclusion just by looking at the words and the patterns and knowing that Noyabri is something like this lah. So Noyabri is a grimace. Noyabi grimace or Noyabi has grimace, and Noyabi, and then Champo, Vulgaris, and Praska were similar to uh, grimace because there's a comic, Gothic, crazy. Okay, so just a guess lah. Okay. Okay, so I think typically, how a word is, what a word means can also determine its usage lah. So what a word means can determine its usage. So meaning Noyabri is somewhat like Genpo, Brasisca, or Vulgaris. And then what does Noyabri mean? Its meaning can be given because Genpo, Brasisca, and Vulgaris are similar to it. But at the same time, how you use Noyabri then also may be able to give it its meaning lah. So in the case of Noyabri, then Noyabri, if Noyabri is if Noyabri, so for example, let me go back. This gibberish example is not very helpful. But this Noyabri leaves with salty sauces. You don't know what Noyabri, but it can be given meaning because of its context around it lah. So Noyabri leaves with salty sauces is saying that the leaves work with salty sauces or they can accompany salty sauces lah. So in that case, then uh, its usage can determine its meaning as well lah. Its usage can determine its meaning. Okay. Okay, so I will leave. I don't see any questions in the chat. So if you have any questions, you can leave it in the chat. If not, I'll leave you with a question here, and then let's come back at 8 o'clock. Okay, let's come back at 8 o'clock. So I'll leave this question here, and let's come back at 8 o'clock. Okay. So Okay. Okay. So it's 8 p.m. Let's continue with what we have for today. Let's continue what we have for today. Give me a moment. Let me pull up some detail. Oh, that was fast. Wow. Chicock's responses are very fast. Uh, he says it's B. Okay, so what's the core difference between lexical approaches and experimental approaches? Okay, so lexical approaches is how to define things with words. Experimental approaches is how you define things with your experience lah. Okay, so would it be A, lexical focuses on how word is pronounced, experimental focuses on how words are being spelled? Doesn't sound correct, right? Never really discussed about this. Lexical understands the logic of a story. Experimental only follows the basic punctuation rules in D. Never really talked about that. And then I think C, lexicals used by humans. Okay, that is not wrong. That sounds correct. Experimental is used by outdated computers. Doesn't seem correct lah. Okay, so the option would be B. So good job. Whoever that all who responded would be good job. Chico. Lexical relies on static predefined dictionary lah. Sounds like very similar to n-grams, right? Experimental defines a word's meanings by observing its relationships with surrounding words. Okay, also a bit of engrams, but there's a bit of slight differences lah. Okay, so technically engram is both lexical and experimental lah. But later word embeddings you'll see is more comprehensive lah, not just the words after, but a bit more than that lah. Okay, so if we look in terms of experimental or vector semantics, we can build words meaning from different forms of data lah. So these are different people and how they postulated uh, uh, how the meaning of words come out lah. So the meaning of a word is its usage in the language. Okay, possible. If A and B have similar environments, we say that they're synonyms. And then you shall know a word by the company it keeps lah. So the words around it lah. Okay, so now we're talking about the experimental understanding of words. So what exactly is the idea of a distribution, or in a sense, what exactly is the idea of experiment? Okay, so one component could be context. So what is distribution? The question mark gives the additional context that is a question. The word what also gives it the context that it's a question. So which words are observed together and what are its neighbors lah? So neighbors, for lack of better of explaining it, for left and for right, for left and right lah. Left and right, not just after it like engrams. As well as the frequency in engrams, if a word is more common, maybe there's a high chance that using your experimental observations, it can be quite probabilistic lah, more common lah. So how often do words occur together? Okay, so experimental semantics accounts for some practical properties of meaning lah. But how then do we implement this idea in practice? Okay. Okay, so let me give you an example. Yeah, I realized that the box is out of place, but experimental definition lah. So if we look at the quite a common word that we see now, right? Like the term vibe coding, it's a perfect real world example of experimental understanding action. So it did not emerge from a technical committee or a linguistic committee, but it was the shifting of experience about how we talk about programming lah. So I think traditionally when we talk about programming, the words surrounding coding are what synthetically. The words surrounding coding were purely syntactic lah. So syntax errors, compilers and debugging were words about coding lah. However, when the definition of vibe coding came out, or somebody pushed the coin of vibe coding and it started to snowball and people used its definition, it resulted in large language. It resulted in the definition of vibe coding being not the person coding, but the large language models that is doing the coding lah. Okay, so in actual fact, vibe Vibe maybe doesn't really come with the word coding, and coding tends to be a human endeavor lah. But now the definitions of coding has changed lah. So AI assisted coding, vibe coding, the company of the words being kept together or the definitions are changing lah. So coding is not strictly human coding lah. There'll be AI and machine coding lah. So new distributions or new experimental definitions start to emerge lah. Okay, so now we are just we're gonna jump into the idea of word embeddings lah. So once we start to figure out what words mean and how similar they are, maybe we can do a very mathematical way to model them lah. So if you've taken mathematics regarding vectors, uh, then your mathematics that hopefully you still remember will come back into play now as you think about a two-dimensional space vector of how words can be arranged lah. So you can sort of see that in the green portion at the bottom, very good, incredible, incredibly good, fantastic, amazing, terrific, nice, wonderful, good. They're all coalesced or they're all put into a singular area and space lah. So all the good words are together. Then if you see the red color quadrant, not good, like bad, worse, incredibly bad. All these are put in the same sector, put in the same sector lah. So are we able to figure out how to do that? So there's definitely the point of view. Learning this for today is the idea of word embeddings. Okay, so typically I like to show this visualization, this website whenever I explain a bit about word embeddings lah. So typically when I teach deep learning also, there's a small segment that talks about word embeddings, not to the deep concept, but to some idea lah. Okay, so one of the models that I have worked with is Word2Vec when I did research with NTU, is that the model that I chose Word2Vec was I was trying to map certain legal codes in a Word2Vec lah. So I was trying to figure out how similar certain one would be one example how similar body parts would be in a vector space lah. Okay, sorry, I realized I didn't give any context, so let me show you first. Okay, so I click into this. Okay, I'll send you the link after this for you to try a bit. But let me show you what this is lah. So the reason why I like this is because it looks like a galaxy space lah. So it's like, oh, what are all these? What are all these? Okay, what are all these? And then with the instructions, you can move forward and back. Wow, and it looks great. And when I go close enough, I see a word, Amex. Don't even know what is Amex. Flyers. Hershey bears. Wow, such thing exists. Flames. Wow, no idea. Okay, and then you see a huge space down here. Okay, I may not be zooming very well. Okay. Sorry. The reason why I like this is that it looks quite cool. That I go through. Oh, I'll go back up. Okay. Scan. Wow, so many words that I've never seen before in my life. Okay, so basically this is a corpus of I forgot what the exact data set is called, but it's the news data set lah. So there are certain corpus of a lot of news documents, and then it's running a Word2Vec model so that it put into the model and is trying to distribute it into this dimensional space lah. So this is, if I scroll out, okay, you will see a huge map of you can think of it as a three-dimensional map of space lah. Oh, so I'm zooming out. I can't see already. Okay, okay, so you can see just scrolling. Oh, a three-dimensional map. Okay, but for the sake of this, I am okay. Let me go back. Maybe go back and just say that you see all this, right? These are just different models that use word embeddings now. I only choose the Word2Vec, but later you can click on them and you can try different ones. Glove is quite a common one that we will do in our lab as well. Okay, sorry to digress. So let's let the map load. Okay, it's loading. It's loading. It's not loading. Okay, okay, it's loading. Okay, so I'm gonna search a word here and see if it exists inside this space lah. So this space is like you put in the Google News documents full of sentences and words, and then it will break it down into this three-dimensional, multi-dimensional space lah. Okay, let's search a word. Okay, let's search university. Oh, so there are many university. Oh, John Hopkins University. Okay, I click on university, maybe the 10 occurrence ones. Oh, the 10 in degree and 10 out degree. Okay, so university is here. 10 in degree means that there are 10 words that are going into it. Okay, sorry, this is not about graphs, but 10 words that are going into it, they are related to it somehow, and then 10 words that are going out, they're related to it somehow. Lah. Okay, so if you see here university, let me see, am I able to peg it to another word? The word that is associated with it. So you can see the universities here, but then when I there you can see there's a relationship between university and faculty lah. So the model, the word to vec model, digests the documents and then it finds a relationship between these 2 points lah. Okay, so you can zoom out. Okay, these 2 points. So university, faculty is quite close to a different spelling of faculty. Small letter F faculty, large letter F faculty, and it's related to undergraduate and it's related to graduate as well. Lah. Wow, this is a very small graph, very small map. Okay, but you can see if I look around at the surrounding words, right? Provost, academic underscore affairs, undergraduate, small universities, they're all roughly in the same area. Lah. So this word embeddings is trying to scope words in a similar area. Lah. Okay, so with that, let me send you this link so that you can try on it while I am talking. Uh, so okay, I'll give you the word to vec one. Okay, so you can click on this link and try the word embeddings out. Okay, so word embeddings are mapping the meaning of words lah. So in this case here, the university faculty, they are all very similar lah. Okay, what if I map Singapore? Or like maybe is there a Singlish word? Copy, copy. Okay, don't have copy. Teh. Teh. There's no teh also. Guess Google News they filtered out certain things. Food. Food of course okay. Can't think of a word that may not have that. School. So if I click on school, it will map me to school. School is in the another way to put it lah. School is quite in the similar neighborhood to university lah. I think. So there's school, preschool. This is a whole cluster, kindergarten, elementary. So this is a whole cluster on its 8th grade lah, graders lah. Okay, so it's its own cluster on its own lah. Okay, so I like this because it looks quite nice lah. Okay, I'm gonna type Singapore. Okay, Singapore with big capital letters. Singapore Airlines. Okay, Singapore. So Singapore is here. Let me zoom out. Let me zoom out. I cannot zoom out. Uh, zoom out. Say Singapore, what is the relationship with Singapore? Somehow this is a cluster of countries. Jakarta, I don't know where's Tehran, Singapore underscore Singapore, Kuala Lumpur. Okay, so this is a map of uh when whatever documents you want to ingest, so a lot of words you want to ingest to it, it will do a map, something like that lah. Okay, and these are the other models. Okay, so maybe take the next 5 minutes to try it out. You can try and see the other text. Maybe you can search the same word and try it in different embeddings now. Okay, so let me send you the this page now, so you can try it out on different word embedding models with the same word. Okay, so you can try it out and you can see a relationship. So just now I searched Singapore is quite close to the map. Maybe I try Glove, which the source is a common crawl of websites. Or can use the Wikipedia one, the fast text, which is Wikipedia. Can try Singapore. Then I click Singapore. Okay, I tried capital Singapore. Wow, there's no capital Singapore here. Okay, clearly there is a bug. Okay, Singapore. Oh, this one has a bug. Okay. Singapore producers. Not sure why this model not very good. Okay. Oh, so Singapore is mapped to Srija, Selangor, Malaysia, I think. Yeah. Okay. So these are different data sets. Like I can see the relationship Singapore is a bit different. Based on the corpus you give it, the way it's mapping is different. Okay. So I'll let you try for a few minutes and to uh see this space. Okay, so hopefully you had fun testing it out. But this is one of the ways to straight away show you word embeddings and how cool it is to see in space. Okay, let me try one more. For the glove data set, let's put Singapore, Singapore, Singapore related to Kong, probably Hong Kong, I don't know. Hong Kong, Malaysia. Yeah. So some of the data sets are, I guess, when it's used, it is very commonly used together with different countries lah. Yeah. Okay. Wait. Actually, then should I just try United States? US. US. Nope. Okay. Okay, never mind. Let's leave it as it is. Let's just continue with the class. Okay, so that's a sample of word embeddings. In case you forget whatever it is, hopefully that visualization can help you stick it into your mind. Okay. Okay, so the idea of a vector space, the important thing is location, location, meaning that because we use that visualization that was quite something like a three-dimensional map, or it could be but sometimes vector spaces can be multi-dimensional. But that's when our minds cannot really comprehend when something is multi-dimensional. But the three-dimensional space is something that you can try and understand. Okay, so one of the ideas and what is really happening in this technical sense is that this vector is being ingested into a way that you are calculating as a co-occurrence vector lah. So every time you see a cherry, what is the chance that you see near it is like computer data result of pi lah. So with cherry and pi is like 442 occurrence and it's closed lah. Okay. So with this two-dimensional space, technically, then you can decide how you want to plot. So digital and information, you can say digital is 6261683. Digital is 1683 with respect to data. So computer and data. You take two columns and then you plot out XY coordinate. So you can say that the point of digital is 1683 and then computer is 1670. 1683 1670. And then you can draw it as a vector, as a line. Information here is 3982, and 3324 lah. Can draw a vector like this lah. And then when you draw this vector, you can do this measurement or this can be your vector space already to decide lah. But you can see there are many columns and there are various ways to do it lah. So this is one example of how this is done. Yeah, this is one example of how this is done. So if you want to read more about it, you can read this paper here. Okay, it's taking a bit long to load. Okay, so it's taking a bit longer. Let's give it time. Okay, you can read this paper on neural networks lah. Somewhere it will explain the vector space. Yeah, somewhere here it will explain the vector space as well lah. Yeah, okay. Never mind. Let's not scroll through something too academic. If not, it will confuse all of you. Okay, so this is how one way to do these spaces lah. Okay, so let me show you a video. Let me show you a video of what this spatial learning is like lah. Okay. Oh, okay. Okay. Cannot full screen. Yeah. There's no sound. So you ingest the corpus into its vocabulary. Let's see. Can I make it bigger? Okay. Let's make it bigger. There's no sound. It's just meant for you to see. So corpus is like, in this case, it's the Wikipedia corpus, and then you're trying to ingest it. So first, what you do for ingestion is that you convert it into its vocabulary constituents. Sorry. And then each word you give it a space in a vector or a map. So with that, the space between different points will then define I mean, now you're plotting all the different spaces. You plot in two-dimensional spaces. And then from there, you can find the meaning of a word based on its context, on the words surrounding it. Okay, so edible and fruit, they will move towards a certain direction. Yeah. Produce an apple, they also move, or they are in some specific direction as a vector. Okay. So there's a word count from here based on the corpus. And then when you want to map these words, these commonly occurring words to a two-dimensional, in this case, two-dimensional, can be three-dimensional only, but two-dimensional. In this case, two-dimensional map. Yeah. So where is shore if you add a new word? Where should it lie on the map? So shore is like lying very close to the word bank. Okay, so this is a sample of the similarity between the word fruit and the distance to other points lah. So then the distance on its own as the vector or the coordinate, that you'll be able to understand how similar it is lah. So that's why there's a similarity distance as well. And you do multiple of these form of distances in your lab as well. Okay, then there will be another example is that man can be quite similar to woman, uncle can be quite similar to aunt, king can be quite similar to queen in where they are in the space. So they're quite near each other and they can point to each other. Lah. When you have 2 points, you can create a vector. Lah. Okay, so that is another way to visualize it. Oh, oops, sorry. Okay, so let's watch this video to better understand the concept of embeddings.
If you're doing anything with language processing, chances are that you need to know and work with embeddings. Embeddings is this concept of representing text and words as vectors of numbers that capture their meaning. Word2Vec is a method that was published in 2013 and was one of the things that helped popularize this idea. In this video, I'll guide you through the illustrated Word2Vec, an article that I wrote explaining the method and how it came to be, and a little bit of the history in its development. Before we get to the article, 2 key takeaways I want you to get out of this. First is that this concept of representing words as vectors. Word2Vec is one method of doing them. We now have better ways of doing them, so that concept is more important than knowing exactly how Word2Vec works. But going through how Word2Vec works gives you a little bit of the intuition of how to build an embedding scheme, how that training works, how massive amounts of text data are used to create these embeddings to make a good embedding vector for each word in our language or in the vocabulary that we're doing. Since Word2Vec came around, there has been certain developments and methods. The main one since this kind of embedding is the concept of contextualized word embeddings. You can find more about that in my articles and videos on BERT and GPT-2 and those kinds of models. But without further ado, let's get to the article. So I'm happy to give you a guided tour of this blog post. It's one of the most visited blog posts on my blog, and it's for a fundamental concept. It talks about word embeddings establishes them, and it talks then about the word-to-vec algorithm. It's still being used, but the concept of embeddings is used way more than just what word-to-vec does. In more recent transformer models, other NLP models, word embeddings constitute a major part of the model size in terms of parameters. And there are other aspects where it's not just looking at the embedding of a word, but the embedding of a sentence or a piece of text. But this always also extends to other types of data, kind of like how images can have their own embeddings, people have their own embeddings. And I start here this post by talking about embeddings of people. And the example I give is that your personality can be represented in these 5 numbers. You can take the Big 5 personality traits test, and it will tell you, okay, from introvert to extroversion, let's say introversion to extroversion, you have this score. So out of 100, you're maybe 25 or you're 58, as in this example. In negative emotion, you're this score here, it's 15. Conscientiousness, agreeableness, and openness to experience. So this is your scores. And then if you take these 5 numbers, that's a kind of embedding for your personality. They describe you a little bit. And if we only take, let's say, one of them, extroversion, and we plot it, and we change the score from 0 to 1 to -1 to +1. So that's, let's say, one dimension of your personality, literally, but it doesn't really describe you. If we wanted to know more about your personality, we'll add one more, let's say, a trait. And so let's choose another one and we add it to the figure, and then from there we have this line. And then we also lose the names, because this is a thing we have to get used to in embeddings, where dimensions don't really mean very much, so they're not connected. Each dimension is not necessarily, or at all maybe, connected to a specific axis of meaning. So we have dimensions and we can't point out to exactly what they mean. So where here we had extroversion, here we start saying, okay, this is one trait of you. And one of the main ideas of embeddings is that if you represent them as vectors or as points, you can compare them. So if you have, let's say, this is one vector for let's say, my scores, you can see that we have 2 other vectors for person 1 and person 2, and we can numerically compare those to me, and we can calculate an actual score of how similar these 2 vectors are, or these 2 personalities are. And with that, we establish sort of some of the main intuitions of embedding. So one is that a lot of things, even people, can be represented by strings of numbers. The more information you want to pack, the more you want to pack into the embedding, you need a larger size embedding and some way of representing that information. And we get to that a little bit later. And then the second one is that once you have things, items, people, products, words, sentences, paragraphs, or books represented as embeddings, you can compare the embeddings numerically using something like cosine similarity. And then from here you can build recommender systems, you can do classification, clustering, you can do so much of that. And if you only leave this video with just these 2 ideas, that is maybe the most important part. Here we try to visualize a little bit of how that looks, how king is represented. So these are the numbers that go into this embedding of the word king. And then you can see that.
Okay, so if you see the details, he said the word embedding here is the word king being trained on the glove vector lah. So the glove vector also exists according to just now that very nice spatial map. Yeah, so glove vector, you can see the vector, like it's
these
quite
2
long.
ideas, that is maybe the most important part. Here we try to visualize a little bit of how.
Yeah, so I'll just then continue.
How that looks, how king is represented. So these are the numbers that go into this embedding of the word king. And then you can see that the embeddings of man and women have a lot of, let's say, color. So this is a way of plotting it to assign color to the value. But I wouldn't dwell too much on this type of visualization. And then we talk about the post goes deeper into language modeling, which is this concept used to be able to train these models. So it's predicting the next word. And we go a little bit deeper into how that works. So we give a model, let's say, two input words, and it has to predict the third one. And from that, we can generate these embeddings. Word2Vec and language models in general are trained on vast amount of text, and a lot of that is done using, you get this text and you then slide this kind of window and you train the model from examples generated from these windows that are sliding. And then the article goes into this visual of, let's say, we have this sentence, thou shalt not make a machine in the likeness of a human mind. And if we're working with, let's say, a 3-word window, we can slide our window on the first position, and that would generate, let's say, 2 input words and 1 output word. And then that's one training example that we can use later to train the model. And then we can slide the window to the next position, and that generates another example. And then we can go the rest of the way and train the model. And then there are a bunch of improvements on how to do this, how to look left and right, this idea of bag of words and skip gram, and these are 2 of the main ideas in Word2Vec. And this concept over, let's say here, of negative sampling and how to make this training a little bit more
Okay, so I think he is rambling a bit. So let me see if I can find the article, and then you can look at the article in your own time now. Okay, so put the article here for you to see. Essentially, he just described a lot of the idea, not just of word embeddings, but a lot of the NLP techniques that need to be learned. So word embeddings is one. Then somehow in his word embeddings, he explained something that you are familiar with, right? Which is the n-grams, right? So he's using the window. Sometimes n-grams is like a window lah, using a trigram window. So trigram, trigram window. Yeah, so trigram, n-grams lah. Yeah, so later we will talk about skip grams as well as back of words, but just this is just to let you know lah. Okay, so there's additional resources for you to see. Okay, so when we look at the idea of distributional semantics, the idea of the experimental semantics, you can see like you can find us right on the riverbank. This man, the slope of a muddy riverbank, and you go for afternoon tea and a cruise along a riverbank. Okay, so with these, what can you do with the words related near it? Okay, so the context, the neighbors. So you can see bank. Near bank there is river, slope, boats, muddy, overlooking, overlooking, slope, overlooking. Where is the overlooking? Overlooking. Okay, may have repeated that. So the context word, the neighbors, how near the words will be near because they exist very near within this corpus of 3 sentences. Okay. So the other example, which was shown in the video, you can find us right on the river bank. Is it? Is it bank? On the muddy river, what? Or along the river, or watching. Okay, so you may think it's bank. It can be bank, but it can also be words that are quite close to bank, right? So if shore is a word that is super close to bank, then it could be bank as well, lah. It could be bank as well, lah. Okay, so this is a sample of a semantic space, lah, the meaning of a word and how close the meaning of a word will relate to each other, lah. Okay, so yeah, this is just the computer science way of modeling these things, lah. Okay, so for the spatial representation, the 2 main ideas is that the first idea is to define the meaning of the word based on its linguistic distribution, how it's used linguistically, and plus when you have the meaning of that word, what you want to do is that you want to map it to a 2-dimensional space lah. So when the word neighbors come up, is that you're saying how nearby certain words are to each other. How nearby certain words are to each other lah. Okay. So the question now is that we will see what is nearby in this semantic space lah. So in this semantic space, when you see the words that were shown previously, they are quite nearby each other because they are related. They are quite far apart because they mean very different things. They're quite far apart, different things lah. So this is just to show you if it's a two-dimensional spatial representation, then representation could be like that. Okay. Okay, so you have this in your slide deck. Uh, these are the two other ways that words are being measured based on the context around it lah. Okay, so let's look at the first one. The SIBO, which is the one on the left. So as shown as the one on the left, the continuous bag of words is to predict a target word based on its surrounding context lah. So the foundation of that word embeddings is that if you're trying to predict the red word down here, it will check the neighboring words lah. So for example, if you use a bigram of we should our environment, the model tries to predict the center word as protect lah, based on the bigram lah. So for this, it's good if you want to predict very frequent words and processing lah. So you can see engrams may be just taking the context of the words here, but then the window size could be the two words that are beside it lah. So we should our environment, okay? And then if you look at the one on the right, slightly different is the word being predicted, or you're using this word to predict the other words lah. Okay, so skipgram does the inverse. It uses a single target word to predict the surrounding words lah. So this word you will use and then try to predict the words beside it. Okay, I won't repeat again or try to repeat that lah. Okay, so just remember that there are different techniques lah. And because we are not going through that in detail now, just shows that uh, these are the techniques that are available lah. Okay, so the method SIBO and skipgram, the model starts with prediction, and is playing a guessing game of guess the neighbor or guess the target to see which words hang out together in the sentence lah. So the context of words. Every time it guesses wrong, it will correct itself lah. So basically, the value of creating the similarity will be like it will try to predict this word, and if it gets it wrong, then that word will have a lower score lah. Okay, so every time it guesses the word wrong, it corrects itself. So it's like model training, effective assigning each word with a specific value and a vector lah, in a two-dimensional space lah. So because of that, then similarity score can be measured lah. Okay, similarity score can be measured in that sense. Okay, so if we define the meaning of a point in the vector space, would then also be called a word being embedded within a vector space lah. So it's embedded in a space, and almost all modern NLP systems use word embeddings because it's quite powerful, and it's one of the best tools in your toolkit as an NLP engineer to use lah. Okay, but the question is, why is it vector lah? So vector is a continuous space, it's a numerical space, and when it's a numerical space, it can compute distances, and with distances, you can compute similarity, and with similarity and that line, you can compute space as well lah. Okay, so yeah, just the different terms and different ideas lah. Okay. So to visualize embeddings, another task that you can test out is this project TensorFlow. So let me try to load this project TensorFlow. Okay, computing PCA. Okay, so you can see this spinning space down here, and then when I hover above is words lah. So it's using the PCA an unsupervised learning algorithm similar to TSNE, an unsupervised learning algorithm, to be able to map the words to decompose them lah. Okay, so I think I will still push through a bit, and then we can take a break later. But this is just to let you know that you can see the spaces over here lah, how they map it lah. Okay, so if you are familiar, so sorry, so if you click the word, you can see the association with the words directly lah. Okay, so maybe I'll just put the link here lah, so you can go and try it lah. Okay, so you can put the words that are close to it with each other lah. So you can click, you can test it, and you can change the distance, or you can check how many neighbors are near it lah. So okay, I don't want to lag my computer by putting more neighbors. But yeah, you can click and you can see the distance of it lah. So that is just another way to show the embeddings lah. Okay. Okay, so uh, let me show you another form of analogical relationships and vectorization. So with this vectorization, you can do some math as well. So you can see these points, right? If they each have a coordinate, you can say like 3 minus apple plus grape equals to vine. So analogical is like making it like an analogy. So a tree without an apple but has grapes on it can be something like a vine. Okay. So when you so for example a tree, you minus apple, you come here, and then you plus grape. Okay, maybe plus grape is not fine. Okay, yeah, 3 you minus apple. Okay, yeah. So I think there's a bit of an issue with this one. But yeah, you can see that certain relationships mathematically can happen. Okay, so these are analogical relationships that are related to each other. But let me show you a sample. Let me show you a sample uh activity, and we can try it together, lah. Okay. Okay. Let me skip this and analogical relationships. Let's skip this. Let me show you this. Okay. So if I click on this word embeddings, uh, this is where this web page is very good and quite fun to play with, lah. Okay, so for example, if I click on uh analogy, right? Uh yeah, man is to king as woman is to something. So for example, if I type man is to king is to woman and then I click go, is queen. Okay. So let me try something else. Okay. Uh food is to person as daily. See if that will give anything. Newspaper. So somehow food is to a person as daily, then the closest similarity is newspaper. Okay, so you can go and try that out, see how it works for yourself. And then similarity score is a vector. So if I type hello and then press go, it will in this vector space it will point out what are the similar words and what are the similarities now. Okay, and then lastly, if I put a group of words and I want to convert it into a vector, and I can say my name is uh me. Okay, then I press go. Then it will map for you in a certain space based on a certain formula lah. So you click the about, I think you can see more of the detail. You can read this as well. So if there are no questions, then let me send this link and then you can try it out lah. So I send this link to you. You can try out and demo and play around with the ideas of the analogy. You can play ideas of similarity, and you can play with ideas of groups. And you can also take a break. So then we can come back at we can come back at maybe 9:05. So you can try it out. You can try it out and take a short toilet break or any form of break that you need. Okay. So try out the analogy, similarity, and groups, and you can read the about to understand better about these word embeddings and what and how this person designed it, lah. Okay. So try that out first, and then after that, uh, come back at 9:05 a.m. 9:05 p.m. when you have taken your break as well. Okay, so hopefully you have time to experiment on the different word embeddings and the possible ways you can use them lah. Okay, so I think that is quite interesting lah, to see and to try because you have a bit more of a visual reference, you have a bit of explanation, the analogy, the similarity, and the group. Yeah, so you have more of that concepts that are available for your at your fingertips to understand. Okay, so it's 9:05. Let's continue on with the last bit for today. So, hopefully, some of it is helpful and you're learning something, and also having a bit of things that you can sort of test out on your own, and not just me talking, lah. Okay. Okay, so now let's think of the definition of now let's think of the definition of distribution. Okay, so word embeddings are the mathematical bridge that allow computers to navigate the nuances of human by translating words uh into a vast dimensional. Okay, so of human language by translating words into a multi-dimensional map of coordinates. Okay, so you should see those mappings and those movements instead of treating a word as a static string of letters, and embedding represents it as a vector of numbers where its position is determined by its relationship to every other word in the language. So words that share similar meanings to contexts like ocean, sea are placed physically close together in this digital landscape. While unrelated what are cast far apart. Unrelated terms are cast far apart. Okay, so this is the geographical space lah. The geometric arrangement enables a machine to calculate a meaning through proximity, allowing it to understand that the apple is a fruit rather than a tech company, based on entirety on the mathematical neighbor which it resides. Okay, so I think you know what embedding definition. I have pounded out consistently, so you should have a better understanding of the definition. Okay, so what are the caveats or what are the possible issues that embedding cannot solve? So embedding, if recorded in its corpus, will reflect cultural bias lah. So or certain biases within the data set lah. So just now when I showed you the embeddings, a lot of it was about when I showed you Singapore, it was embedded that Singapore generally associated with those different countries. There's some form of bias that is there lah. Or in some sense, the father minus doctor plus mother equals to X, and maybe father minus doctor plus like a mother could be a nurse lah. Or man minus computer programming plus woman equals to homemaker. Maybe there's some form of cultural bias that exists. And it only works well with more frequent words lah. So if you have words to capture, means you have a data point, you can use embeddings because you can form an embedding map because the words are actually being used. So in a certain sense, just now when I try another embedding, I tried to find Singapore, and Singapore is a bit rarer. So Singapore, if it's not a frequent word in the corpus, then it does not work very well lah. Okay, so Zipf law sort of holds common that we do use certain words more commonly. So for example, the word example, the word we, the word she, the word he. So certain words are more commonly used than other words lah. And some rarer words, if not common, will then not show up very well on the map. Okay, so unless the world comes to a stop, words will continuously grow lah. So the example of byte coding for today is that the new words will increase and then the vector space will always increase in size because more words will always exist and more words will come into creation. And embeddings only work well with certain relationship types. So uh country capital as part of the speech, it does work only with certain relationship types well lah. So meaning country as a capital, as a part of speech, there's a relationship there lah. But if words don't have relationships, then it may be a bit confusing and maybe a bit unexplainable lah. At the same time, words with similar meanings like apple can be a fruit or can be a technological company, or banks, river, and finance can't really be handled very well because there is no no because the word takes on different meanings lah, but they will still be mapped as the same word inside the vector space lah. They'll still be mapped as the same word inside the vector space. So it does not handle words that have similar multiple meanings of with the exact same word. Okay. So one thing that just now that video explained is that the next step towards embeddings would be the contextualized embeddings lah. So we should protect our environment is the text that we are using. So the input is, in this case, you can see in the box on the right, we must protect our environment. So mask is like you are asking the model to predict the mask, but you're giving the words around it as the input lah. So in this case, the we must protect our environment. The model predicts the mask with we protect our environment as more details lah. Or similar to that, the input is such that we protect our mask. So it's having all the words before that as an embedding lah. So this is an example of contextualized embedding. So he also mentioned very interesting words like BERT, GPT-2 just now in the video. So contextualized embeddings are the very basic large language models lah. So before GPT, BERT was one of the more popular models that was being used lah. So Roberta is also an example. So all these models, of course, you can find in Hugging Face, and these models work on the idea of contextualized embeddings lah. I think there's no slide for this, but it's the idea of attention lah. So it's putting an importance of when you want to predict a word, it's taking the whole corpus and then it's using all the words in the corpus to predict that word. That is the idea of attention in embedding. So that is a common concept. If you want to learn more about transformer models, then attention is somewhere there. I think we'll go through that in one of the seminars as well. So contextualized embedding will be explained a bit more in the lab. I believe. So we won't. I won't explain the context, but I won't explain the topics. But contextual embeddings will be the next step for embeddings. Okay, so it's a question for you to think. Since I think we have gone through most of the content for today, so now you know about engrams and you know about embeddings and a bit of contextualized embeddings lah. Okay, so select all the following statements that are true regarding how AI models process and map language. Okay, so select which one you think is true. Okay, so I see responses. Thank you, Chikok, for your response. Okay, I see Yu Hai also has a response. Thanks so much for responding with your options. Okay, don't feel peer pressured, even though both their options are the same. So feel free to attempt this lah. Okay, you don't have to write it down, but just feel free to attempt it because ultimately you have assessments and you need to know the concepts lah. So hopefully you'll pick up these concepts, but at the same time, more importantly, if you're going to be an NLP engineer, then these concepts you should roughly know what they are lah. Okay, so okay, maybe let's wait 10 more seconds for any last brave soul that wants to respond. Any last brave soul that wants to respond? Okay. Okay. So you have your options. You have seen your options. Now you see if you got the options right lah. Okay. Okay. So good job, Chikok and Yu Hai. Good job. You got the options correct. So red means true lah. Okay. So just to go through word embeddings, use some form of math lah. So similarity, relatedness, and math to make a map Okay, n-grams are primarily focusing on word sequences, while word embeddings are focused on meaning. And then contextualized embeddings, just mentioned, is like a new level of word embedding that works well, lah. And then word embeddings are not considered static because they work for different corpuses, lah. Yeah, because it's not because they use masking as well, lah. Okay, that unlike traditional sequences, contextualized models can use the entire sequence to predict and unmask. Okay, so these are the meanings that you should have taken note for today. If somebody asks you for interview, what kind of tools you need for NLP, you should say n-grams, word embeddings, contextualized embeddings. Okay. Okay, so another question for you to think about and for you to because I think we're coming to the end of the content, so just exercises for you to think about. Okay, so this is a option A, option B question. So a fintech company is developing an NLP system with two components. Okay, so in realistically, if you are the company head, you're developing an NLP system and you're in the data science team now, you want to develop an email filtering module that flags promotional and phishing material by detecting repeated patterns such as act now, limited offer, and verify your account. Okay, so commonly for cybersecurity, using flags to pick out specific words are one way to predict whether something is phishing. Okay, and a customer support chatbot, they must understand user intent even if the words used are different, such as recognizing loan, credit, financing, and refer to related concepts. Okay, so the data science team must choose between two different text representation for each component to balance accuracy and computational cost. Okay, so which of these options fit this scenario? So option A is that use n-grams for email filtering module and word embeddings for the chatbot. Option B is that you just use word embeddings for the email filtering module and n-grams for the chatbot. Okay, so yeah, okay. So good, some responses. Thank you, Chikok. Thank you, Tina, and thank you, Royden. Okay. So some responses. Let's give a bit of time for the others to think as well. But thanks for your responses. Okay, so I think everybody has some time to read it. Even if you didn't respond directly, just look at the option and the response, not the response, the explanation. Okay, so engrams is used for the email filtering because the act now and the limited offer is like the bigram, right? And then the verify your account is like the trigram and how many times it occurs, lah. So that would be the fastest way. You can use word embeddings also. Technically, you can use all ngrams word embedding. You can use all at the same time. You can throw every single tool that you learn to do it lah. But then, of course, ngram seems to be the better suited tool for this. And there's chatbot. I think you already realized now, like the GPT chatbot, any form of chatbot, the word embeddings are the best to find the relationship between meanings lah. Okay, so so the other definition is here lah. So which is recurring phrases and local word patterns. Ngrams would be the good use of it, and then chatbot requires a semantic capturing and similarity for it. Okay, so good. I think most of you should be on the same page and you have gotten the concepts down. Okay, last question for today, which is a open-ended case study question. So if you want to integrate engrams and word embeddings, a social media platform wants to improve its content moderation system. So of course, I'm giving you questions that exist and how you can apply engrams and word embeddings, right? So a social media platform wants to improve its content moderation system. The system must quickly flag posts that are harmful or ban phrases. It must also detect semantically similar content where users avoid exact wording but express the same harmful intent using difficult vocabulary. Okay, so think of it as a way to justify if this is a real problem that you have. How would you design an NLP pipeline that integrates engrams and word embeddings to meet both requirements? Okay, so in your answer, describe the role of engrams in the system. And describe the role of word embeddings in the system and why using both is more effective than using one approach. Okay, so Of course, there's a lot of theory, but if you can apply it and you can explain it, then it would be helpful lah. Okay, and then this also shows you have greater understanding of application of whatever you just learned. Okay, so if you're able to type your answers to this, that will show that you are thinking and you understand the concepts well. So let's leave it here for some time so you can respond to this. Okay, so I see Chikop's response. Thanks for the responding. Yeah, so let's give time to for other people to thanks for always replying first. That's good to know that you're thinking. So that's good. Let's give other people a bit of time to think as well. Because I think ultimately there's too much theory, but you should think about how to apply these concepts lah. I mean if you don't know how to apply, then uh you may forget. Number one, you may forget. Number two, uh based on how you apply, that's actually how you get a job and make money lah from it. Okay, great. So we have three responses. Thanks for the response. Chikok's response, Yuhai's response, as well as Royden's response. Great. Okay, I see that. So in case this chat cannot be seen for the recording, so I'll just read it out in case of whoever's uh I mean I'll summarize it lah for each person's lah. So it is true. So Chikok says that the use of engrams is on the all the list of harmful or banned phrases. And use word embeddings on this list. Okay, that's an interesting way to put it. If you want to combine both lah to get the relational words. Okay. Yeah, that could be one way. That could be one way lah. You have the engrams of those words. Yeah, you can have engrams of those words. But maybe a certain con in that is that the engrams only works for more frequent words lah. So those semantically similar content, but they're not common words, then it may be a bit hard to predict as well. But yeah, I believe it can work lah. So it's one strategy to try it as well lah. So of course, one of the things about machine learning, when I show you the NLP day in the life, is a lot of experimenting lah. You may have an intuition if something works or not, but you still must test it. Okay, so that is thanks, Chikok, for your response. Actually, I didn't expect. Okay, no, I think it's possible. It's a possible expectation, but that's good. That's nice to hear. Then another summary by Yu Hai one is use engram as the first filter of harmful or banned phrases. Use word ending to amplify harmful words through related meanings. Okay, okay, so quite similar. Both engrams for first layers. Yeah. Wow, when being okay. I think quite similar, but a bit different, I think, from what Chikok is saying lah. A bit. Okay. Then what Royden is saying, engrams are effective in catching exact or near matches fast. Okay, yeah. Definition's good. Engrams definition good, embeddings definition good. So the hybrid of both improves accuracy and coverage to reduce false negatives and false positives. Wow. Okay. Interesting way to put it. Yes. Wow. Okay. Last week you never go through false positive, false negative, right? But okay, that's good. I think you know false positive, false negative. So, uh, uh, so I think the reason why you want to use both, yeah, is the false positive, false. It's a multiple test lah to see whether it will work as well lah. Okay, so that's good. I think Royda answer the questions directly. Chikok and Yu Hai answer the questions as how to implement it lah. So okay, those are still good answers. Thanks so much. Can see you are thinking of how to solve the problem. Which is good. Okay, then Amanda has a response also. So thanks, Amanda, for the response. Engrams to match the post, yeah. Post not flag the embedding vectors. Okay, point one. Why using both is effective filters obvious cases of semantic similarity. Okay, good, good. I mean, you're using the terms that are in today's class lah. So similarity lah. So if you haven't done machine learning yet, so similarity is the key thing lah. You want to whenever you have numbers, you want to make it similar, and you want to figure out how these numbers can be similar lah, how close they are, how far they are. Okay, so it's very good. I think good sense. I think from what Chikok and Yu Hai said also something that I didn't expect that y'all will try to implement it and how to implement. But very good. This is a very good answers to hear lah. Okay, so now you're thinking more like NLP engineers, and that would be a possible way to find a job there if that's what you want to. Okay, so thanks everybody for participating. I appreciate your participation. So that is mostly today's the content for today. So with that, you should have the ability to attempt your TMA question 3 lah. So your TMA question 3, you can go and see it yourself. If I'm not wrong, it's just converting embeddings. I think so, converting embeddings. Yeah. So for lab 2, next week we will also revisit the idea of embeddings. We will understand the code bases. When we revisit the idea of embeddings, you still must go back to the same idea of tokenization, how to do tokenization. And then after that, the work embedding training pipeline and how to improve work embeddings, how to do contextualized embeddings as well lah. Okay, so just for a short summary for this week on the lab is that you have the notebook, you can access it yourself. If you still cannot use Kaggle, then by all means try to look at the previous lab last week and see how you can do use a Kaggle notebook lah. Okay, so in this case, there'll be tokenizers. So for next week I'll go through. So there'll be tokenizers. There will be the same co-occurrence matrix, which is how often words appear next to each other. PMI matrix is another way to also measure how two words appear next to each other. Cosine similarity matrix. So a lot of math related concepts that we'll go through. So this is quite similar to the base notebook, but of course I'll give you a more advanced notebook. So cosine similarity is also about distance, how near, how far different points are. Uh, and then of course I showed you a lot of visualizations today, but what is this visualization using PCA, principal component analysis, to be able to decompose all the different columns and then how to visualize it. So to create a visualization for different points in different areas now. Okay. So so how then you mark out all these values lah. So similarly, when I was trying to map different legal cases together, then how the distances will be done. And then we also use OpenAI's fast tokenization library to convert numbers into tokens so that models can be processed language mathematically and fast. And then a lot of vector things lah. Okay, so I'll go through all this and the word analogies. You'll be able to use the data from Glove, which you saw regarding the what's it called? The word embedding model, like the word to vec, and another one's called Glove now. So we'll go through all these details. And then we will try to evaluate certain vectors that are being trained on the models lah. So then there'll be 1 gram, 2 gram, all this kind of different file names that exist now. Okay, so there'll be a lot of file names. We evaluate the vector to see if it's going well now. Okay, then besides that theory, I'll probably add on more detail to this notebook as well. And then we'll be able to do more experiments lah. Hopefully, it seems like I will try to see if I can add in more questions that are more practical lah, instead of just the theory for next week's step. Okay, so with that, uh, that is the end for today. Today is not a very long today's not a very long lesson, not a very long seminar. So if you are able to, I mean, just hopefully have a good night's rest as well as good weekend. And I'll see you if you're coming for lab 2 next week, and then we'll talk about. I'll give a bit more practical examples lah, on how embeddings can also be used. Okay, on how embeddings also can be used. Okay, so with that, this is if you have any questions, you can stay and ask. If not, have a good weekend. And if you want to attempt your TMA question 3, you can do that as well. So have a good weekend, have a good Friday night, and I'll see you next week. Yep, and thank you all for participating. Yeah, appreciate the participation as well. Okay, if any of you have questions, can ask if you have any questions. Okay, if not, probably end this call and have a good weekend to both of you. Okay, bye bye.